17 drones, each costing less than a luxury car, about to turn $500 million of Russia's most advanced air defense system into scrap metal. What you're about to witness isn't just military history in the making. It's a masterclass in how modern warfare has been completely revolutionized. The story I'm sharing today proves that in today's conflicts, a brilliant mind with limited resources can outsmart the most sophisticated military technology on Earth. On a clear morning in late June, as the Crimean Peninsula awakened under the rising sun, Russian radar operators had no idea they were about to become part of one of the most stunning military defeats in modern history. The time was just past 3 in the morning when a massive S-400 radar dish began its routine sweep across the sky, pumping out enough electromagnetic energy to literally cook a turkey from 10 kilometers away in just 15 minutes. This wasn't just any radar system. This was Russia's crown jewel of air defense, a technological marvel that had protected critical infrastructure for years. But high above the Black Sea, 17 Ukrainian drones were already airborne, flying in perfect formation like a pack of electronic wolves hunting their prey. The lead drone, a sturdy Beaver model, had been burning fuel for over 2 hours at this point, consuming 12 liters every hour as it maintained its steady course toward destiny. With current fuel consumption rates, the mission parameters were brutally tight. 19 minutes to locate the target, 2 minutes to destroy it completely, and just 2 minutes of buffer time in case anything went wrong. In military operations, these margins aren't just numbers on paper. They're the difference between victory and catastrophe. The drone formation spread across a 3-kilometer front, maintaining a precise altitude of exactly 50 meters above the rolling Crimean landscape. This specific height wasn't chosen randomly. It was calculated based on pure physics that no amount of Russian engineering genius could overcome. At 50 meters altitude, the Earth's natural curvature creates what military experts call a radar horizon of roughly 25 kilometers, essentially creating a blind spot that even the most advanced radar systems cannot penetrate. Think of it like trying to see someone hiding behind a hill. No matter how powerful your binoculars are, the landscape itself blocks your view. The S-400's mighty radar arrays, capable of tracking ballistic missiles screaming through space at incredible speeds, found themselves completely helpless against these low-flying intruders. Physics, as they say, doesn't negotiate with anyone, not even with Russia's most advanced military technology. These radar systems could detect a baseball flying at 100 kilometers distance, but the drones flying below the radar horizon might as well have been submarines cruising underwater for all the good the radars could do. Behind the 7 leading Beaver drones, 10 additional aircraft called Scythes maintained their assigned positions in the formation. These weren't sleek military aircraft fresh from some high-tech defense contractor. They looked exactly like what they actually were. Plywood boxes with wings, assembled in repurposed furniture factories by workers who had previously spent their days crafting kitchen cabinets and bedroom dressers. Each scythe carried a base price tag of $15,000, with an additional $30,000 for the guidance systems that would make this mission possible. The return on investment calculation would make any Wall Street financier weep with envy. 17 drones with a combined cost of $425,000 were preparing to attack a defensive battery worth $500 million. But first, they had to actually reach their target, and that meant navigating through what had become known as a GPS jamming nightmare zone since the conflict began. The navigation system relied on what engineers call triple redundancy, because in Crimea, traditional GPS signals had become about as reliable as weather forecasts. Each drone carried a commercial GPS chip that cost just $12 on online marketplaces, backed up by sophisticated accelerometers and gyroscopes that tracked every subtle movement and course correction. But the third navigation system represented pure Ukrainian ingenuity at its finest. Optical cameras that continuously compared the terrain below to stored satellite imagery, creating a visual map that no amount of electronic jamming could disrupt. Russia might jam satellite signals and scramble radio communications, but they couldn't jam what the engineers playfully called eyeballs, the simple act of looking at the ground and matching it to known landmarks. This low-tech solution to a high-tech problem would prove to be one of the mission's most brilliant innovations. As the formation approached the target zone, the swarm executed what drone operators call program dispersal, a carefully choreographed dance of destruction. 7 drones climbed to 80 meters altitude, still well below most radar coverage, but high enough to execute devastating diving attacks. 5 aircraft maintained their original 50-meter altitude, while the remaining 5 dropped even lower to 30 meters, using the terrain itself as a shield against enemy detection. This vertical spread created what military tacticians call a 3-dimensional nightmare for defenders, forcing them to divide their attention across multiple altitude bands while tracking targets approaching from different vectors simultaneously. It's like trying to swat multiple flies buzzing around your head at different heights. Your attention gets scattered, and your reactions become slower and less effective. On the receiving end of this approaching storm, the S-400 battery near the town of Jankoy continued its standard overnight routine, blissfully unaware of the technological apocalypse heading directly toward them. The primary radar system, nicknamed Gravestone by NATO forces, rotated once every 12 seconds in its endless search for threats that weren't supposed to exist. A secondary radar called Big Bird searched deeper into the sky, looking for high-altitude intruders that might be approaching from the stratosphere. 4 missile launchers stood ready with 16 surface-to-air missiles, while 2 additional Pantsir defense units provided close-range protection. On paper, the numbers suggested this battery should be virtually untouchable by any conventional attack. The reality was about to prove that 17 basement-built drones could rewrite the rules of modern warfare. The Russian operator staring at his radar display suddenly found himself looking at 17 distinct contacts at 32 kilometers distance. His Panzer battery could theoretically engage about 3 simultaneous targets, maybe 4, if the targeting computer didn't overheat from the processing load. Simple mathematics revealed a terrifying truth. 17 targets divided by 2 Pantsir systems meant more than 4 targets per system, and that assumed they could even detect and track the incoming drones effectively. The Pantsir's maximum engagement range stretched to 20 kilometers under ideal conditions, but its effective range against small aircraft dropped to 15 kilometers. Against missiles, that range contracted further to 10 kilometers, and against targets with radar cross-sections smaller than 0.1 square meters, the effective range collapsed to just 5 kilometers. These incoming drones registered at 0.05 square meters on radar, essentially making them nearly invisible until they were almost on top of the defensive systems. The mathematics of modern warfare became brutally clear as the operator calculated his impossible situation. 17 drones spread across a 3-kilometer front, approaching at 48 meters per second, meant he had exactly 104 seconds from the 5-kilometer mark to impact. His Panzer system couldn't fire 12 missiles without reloading, and the reload process required 5 full minutes, time he simply didn't have. Each successful engagement required a minimum of 2 seconds for target acquisition, 1 second to fire the missile, 6 to 8 seconds of flight time to reach the target, and approximately 2 seconds to assess whether the target had been successfully destroyed. Under perfect conditions, this meant 11 to 13 seconds per drone. 17 drones multiplied by 12 seconds equaled 204 seconds of engagement time, but he had only 98 seconds available before the first drones reached their targets. 20 kilometers to the north, the massive Big Bird radar continued its methodical rotations, completely oblivious to the approaching swarm. This L-band monster could detect objects 600 kilometers away and track 300 targets simultaneously, with enough sensitivity to spot a baseball at 100 kilometers distance. But its minimum altitude coverage was 100 meters, making the 50-meter altitude drones effectively invisible to its sophisticated sensors. The S-400's missile launchers remained in standby mode, each vehicle carrying 4 missiles for a total of 16 in the battery. In theory, they could engage 16 targets simultaneously, but theory and practice often diverge dramatically in combat situations. Without precise targeting data from the tracking radars, those $1.5 million missiles would be reduced to expensive fireworks with no hope of hitting their intended targets. As the geometry of the attack grew worse for the defenders, the drones adjusted their course, spreading their formation to 5 kilometers and approaching across a 90-degree arc. The Pantsir turrets could traverse at 45 degrees per second, but tracking multiple targets across such a wide arc meant constant movement back and forth, burning precious seconds with each adjustment. The second Panzer unit, positioned 800 meters south of the first, faced identical mathematical challenges with identical results. Between the two systems, they had 24 ready missiles plus 16 reloads, normally more than sufficient against conventional aircraft or helicopters. But against a coordinated drone swarm employing modern tactics, they would need to achieve a 100% hit rate and would still run out of ammunition before eliminating all targets. The irony was absolutely perfect in its cruel efficiency. These radar systems could track objects orbiting in space, and their missiles could reach into the stratosphere to destroy targets flying at the edge of the atmosphere. But against 17 drones built in converted basements, flying lower than treetop height and costing less than most people's cars, the entire sophisticated system might as well have been defended with harsh language and pointed sticks. Just a few kilometers from their targets, the Panzer targeting computer finally achieved radar lock on the first drone, then the second, before stuttering and struggling to assign targeting priorities to 15 additional contacts. All the targets presented identical thermal signatures, all boring in at the same relentless speed, creating a targeting nightmare that pushed the system's computational capabilities beyond their designed limits. The operators could actually hear the computer's cooling fan screaming as it desperately tried to solve 17 simultaneous engagement equations while the clock ticked down toward catastrophe. The first missile left the rails 12 seconds later, accelerating to 3 times the speed of sound in just 2 seconds as it raced toward its target. The computer had determined that the closest threats were already within minimum engagement range, leaving a flight time of just 6.3 seconds to intercept. The missile's proximity fuse searched frantically for radar returns large enough to trigger detonation, but found nothing substantial enough to engage. The missile passed within 2 meters of its intended target and continued harmlessly into the dawn sky, its sophisticated guidance system defeated by the drone's minimal radar signature. Recognizing the problem, the operator switched to manual targeting mode, using optical sights to track the dark shapes now clearly visible against the lightening sky. The second missile launch proved more successful, with the proximity fuse working as designed and shredding one drone with tungsten fragments. 1 down, 16 to go, but the relentless mathematics of time and ammunition remained unchanged. From Belbek Airfield, 85 kilometers northwest, 2 Su-35S fighters launched on full afterburner, their pilots having received scramble orders 90 seconds earlier. At maximum thrust, they consumed 400 liters of fuel per minute while rocketing toward the target area at 19 kilometers per hour. Flight time, 8 minutes. At this rate, they would arrive just in time to photograph the wreckage and file their after-action reports. The second Panzer joined the desperate fight 10 seconds later, its operator firing in full automatic mode as the computer launched missiles as rapidly as the system allowed, one every 3 seconds. Tungsten fragments filled the air like lethal confetti as 2 more drones disappeared in puffs of smoke and shattered composite materials. 14 targets remained, but physics had definitively entered the conversation. The surviving drones executed their final attack profiles with mechanical precision. The high-altitude group began diving attacks at 30-degree angles, increasing their closure rate to 65 meters per second. The low-altitude group dropped to 20 meters, using terrain masking to break existing radar locks and disappear from tracking systems. The middle group maintained steady approaches, forcing defenders to split their attention between multiple threat vectors approaching from different directions simultaneously. Both Pantsir systems ran completely dry of ammunition just after the 4-minute mark, having expended 24 missiles to destroy 5 drones. 12 threats remained airborne and closing fast. Reload time required 5 full minutes, but time to impact had shrunk to just 68 seconds. The operators switched to cannon mode, but everyone understood the grim statistics. Trying to shoot down these small, fast-moving drones with cannon fire was like attempting to hit mosquitoes with sniper rifles. The S-400 launchers finally received authorization to engage, but without precision targeting data from the destroyed tracking radars, they were essentially firing blind into the sky. 2 missiles worth $3 million arced upward in a desperate gesture, designed to hit aircraft at 200 kilometers, but useless against drones at 2 kilometers distance. Both missiles self-destructed after failing to acquire any legitimate targets. The Russians knew their situation had become hopeless as 12 drones penetrated inside 500 meters, approaching from 7 different vectors at 3 different altitudes. The defensive systems couldn't traverse fast enough to engage them all, and the operators found themselves in the surreal position of being able to see, track, and even smell their approaching doom while being completely powerless to prevent it. The first Beaver drone connected with the primary tracking radar at exactly 4 minutes and 47 seconds after the initial detection. Its 20-kilogram shaped charge transformed $50 million of Russian engineering into abstract modern art in a fraction of a second. Ukrainian engineers had calculated the optimal standoff distance, cone angle, and explosive composition with mathematical precision. The copper liner, just 3 millimeters thick, inverted and stretched into a superheated jet moving at 23 times the speed of sound. This molten copper spear punched through the radar's protective housing, the waveguide assembly, the transmitter modules, and emerged from the opposite side, leaving devastation in its wake. 37 seconds later, the backup tracking radar took a direct hit from the 7th drone, which had approached from the opposite direction to catch the system mid-rotation. The shaped charge struck the antenna feed horn, the most vulnerable point in the entire radar system. The explosion traveled down the waveguide like a directed energy weapon, systematically frying every electronic component in sequence. The massive radar dish, 8 meters in diameter and weighing 3 tons, sheared off its mounting system and crashed to the ground with the sound of technological thunder. At 4 minutes, 48 seconds, and 22 hundredths, 2 Scythe drones hit the northern Big Bird radar simultaneously with 32-kilogram warheads. They didn't require the precision of shaped charges. Pure explosive force accomplished the mission objectives. The first warhead cracked the radar's base structure, and the second, arriving 7/10 of a second later, found the weakened metal and tore the entire assembly apart. The 40-ton antenna array, designed to survive hurricane-force winds, collapsed like an elaborate house of cards. The battery had become completely blind to the outside world. At 4 minutes, 48 seconds, and 45 hundredths, the 13th Scythe found its primary target, a missile launcher worth tens of millions of dollars. The warhead punched through 20 millimeters of armor plating and detonated inside the missile magazine, where the solid propellant normally stable under routine conditions, became violently unstable when exposed to detonation shock waves. The missile ignited, and solid rocket propellant began burning at 2,800 degrees Celsius. The launch tube, designed to channel thrust downward during normal operations, now channeled it upward as the pressure spike reached 300 atmospheres in 3/10 of a second. The tube ruptured catastrophically, spraying burning propellant across the remaining missiles, which ignited in rapid succession. 12 kilograms of high-energy propellant converted 3 missiles worth $4.5 million into the world's most expensive firework display. The last 3 Beaver drones converged on the southern Big Bird radar in the final act of this technological symphony of destruction. 3 impacts, 3 detonations, 1 inevitable result. The radar, already damaged by shrapnel from the burning launcher, absorbed 60 kilograms of high explosives in rapid sequence. It didn't merely collapse, it disintegrated completely, with fragments raining down across a 200-meter radius like metallic snow. When the Su-35 fighters finally arrived, their pilots found themselves staring at a scene that would redefine their understanding of modern warfare. 4 distinct fire sources sent black smoke columns 500 meters into the morning sky, while secondary explosions continued cooking off in the wreckage below. The pilots circled once, confirming what their sensors already indicated. The S-400 battery that had protected western Crimea for 3 years had been completely annihilated in just over 3 minutes. 17 drones built in converted basements, powered by lawnmower engines, and guided by smartphone processors, had proven that in modern warfare, ingenuity truly is the great equalizer. This wasn't just a military victory. It was a demonstration that the future of conflict belongs not to those with the biggest budgets, but to those with the most creative minds. The implications of this engagement extend far beyond the immediate tactical victory. This operation proved that asymmetric warfare has entered a new era, where small, distributed, and intelligent systems can overwhelm even the most sophisticated, centralized defenses. The age of the megaweapon may be drawing to a close, replaced by swarms of smaller, smarter, and infinitely more adaptable machines. What happened over Crimea that morning wasn't just about drones versus radars. It was about the democratization of military technology and the leveling of playing fields that were once dominated by superpowers with unlimited budgets. The future of warfare had arrived, and it looked nothing like what the textbooks had predicted.